Hello everyone, this is Grade 3, Module 7, Lesson 22 homework. Number 1 says, the following line plot shows the number of rectangles a student made using square unit tiles. Use the line plot to answer the questions below. So just looking at this, I can see that we're counting by twos here. So we have all even numbers, and 1x represents one rectangle. So A says, why are all of the perimeter measurements even? Do all rectangles have even perimeters? Well, it's a good question. They're all even, meaning 2 or 4, 6, 8, 10, 12, and so on, because we're talking about whole number measurements for length and width. And when we do this for rectangles, we're always going to be doubling the number, meaning if I have 1 and 3 here, 1 plus 3 is 4, and I double that to get the perimeter, because I've only done half of this. I've done 2 of the 4 sides. So every time we double a whole number, any whole number, it's going to be an even number. So that answers the first part of it. So there's the explanation we just had. And now the second part says, do all rectangles have even perimeters? Well, they do with the ones we're working at, but no, not every rectangle has an even perimeter. Because if I draw one here, and I do one side as, let's say 10, and this side is 5.5, we're not going to get an even whole number or an even number. We might get a fraction with that. We might get a decimal. We might get an odd number because we're using non-whole numbers when we put a fraction in there. So my explanation is going to say, no, all rectangles don't have an even perimeter because what if the sides aren't whole numbers? That would make the perimeter either be odd or it wouldn't be a whole even number. It would have some sort of fraction or decimal with it. And there's the explanation right there. And the big one we want to keep in mind is that if the side lengths are not whole numbers, then you won't always get an even number. Sometimes you will, but sometimes you won't. You could get an odd number or possibly a mixed number, meaning a whole number and a fraction, or we could even put decimals in there as well. So let's move down and take a look at C. How many x's would you draw for a perimeter of 32? Explain how you know. Well, this goes directly into B a little bit. We're looking for a pattern here of the x's. And I see for every 2 perimeter measurements, and I'll do this in blue, so every 2 we're going up 1x. So you see that 12 and 14 have 3 x's, 16 and 18 have 4, 20 and 22 have 5, 24 and 26 have 6, 28 and 30 have 7, so 32 and 34 should have 8 x's because the pattern is going up 2 every time. So there's my explanation right there. I would draw 8 x's because the pattern is going up by 1x for every 2 perimeter measurements in my line plot. 28 and 30 have 7 x's, so 32 and 34 should have 8 x's because we're going up by 1x on the next 2. Let's take a look at page 2. Lewis uses square inch tiles to build a rectangle with a perimeter of 24 inches. Does knowing this help him find the number of rectangles he can build with an area of 24 square inches? Why or why not? Well, we know that if we're looking at perimeter of 24, I'll do a quick example of this. We want to divide it by 2 to get our 12. And that's where we can build our addition statements off of. So if I do 1 plus 11, that's going to get us 24 as a perimeter. But it's going to get us 11 as our area. So it's not really going to help us because if we look at area of 24, we find factors or two numbers that are going to give us 24, like 1 times 24, 2 times 12, 3 times 8, 4 times 6. Those are the four that will make rectangles with an area of 24. If we look at what ones will make perimeter of 24, we just need to find all the ones that are going to make 12. The addition statements. So 1 plus 11, 2 plus 10, 3 plus 9, 4 plus 8, 5 plus 7, and 6 plus 6. This one has 1, 2, 3, 4, 5, 6 different options to get us a perimeter of 24. So it's not going to help us out with finding different number rectangles that he can build for area of 24 by knowing the perimeter, because the perimeter could be different on each of those areas for 24. There's only 4 options to find the area of 24. There's 6 for the perimeter. There's my answer statement right there at the top. No, it does not help him because the number of rectangles he can build with a perimeter of 24, 6, is not the same as the number of rectangles he can build with an area of 24, 4. Let's take a quick look down at 3. Esperanza makes a rectangle with a piece of string. She says the perimeter of her rectangle is 33 centimeters. Explain how it's possible for her rectangle to have an odd perimeter. I'm not going to write this one out, but we talked about it a little bit earlier. In order to have an odd perimeter, then one of her side lengths is going to have to be either a fraction or a decimal, meaning it can't be a whole number. So when we say this, we'll say one side length isn't a whole number. And you're obviously going to write this a little bit better because you need an answer statement for this or complete sentences. I'm getting my ideas down right now. I would then elaborate more in my statement, but I'll leave that to you. Thanks for watching. Hope this helps, and good luck on the rest of your homework.